I'm going to demonstrate how to do the train test split approach when you are going to do regression using scikit-learn. So this is where the whole machine learning concept comes around. Whereas the first approach that I ended up discussing doesn't really use any sort of machine learning techniques, so to speak, because in this example that I did earlier, what I ended up doing is create a model using all of the data. So I used all the data related to TV expenditures, all the data related to unit sales, split them into X, Y variables, and just made use of it in the model. Now, when I say split, I just put them in their own respective variables, like this kind of subsetted all the values, the particular values that I want. Now, what I'm going to be doing next in this train test split approach, I'm going to make use of scikit-learn's object called train test split. And I've already used that import statement above in my notebook. And I don't need to rerun that. It's still in memory, but I do have some documentation links right here that you could review. But I'm going to stick with this standard way that the documentation presents how to label your variables, right? And this is kind of standard when it comes down to using the train test split. So what we have here are 4 variables that are being defined at once. You can see the comma separation right there. So we've got capital X train, capital X test, Y train, Y test. And then we have the assignment operator, and then we have this function. This function contains a lot of different parameters, and we're going to be making use of some of these. I'm going to be I have to indicate the arrays, which is going to represent my feature of the model as well as the target. And I'm going to keep it the same type where the features of television, expenses, and TV is a target that we're trying to predict based off of TV expenditures. Now there's something called test size, and that is this is going to accept a float, and it's a proportion of the data in your data frame that's going to go into the test size, right? So for example, if we had a data frame that contains 100 records, 100 data points, then if we say 20% or 0.20, then that means that 20% of the data is going to go to the test, right? So then 20 observations would go to the test subset, and then the remaining would go to the train, right? So we can play around with that or just leave it as none. If we leave it as none, that means if we review the documentation further, then that means that it's set by default 25%. So if I don't want to make use of that keyword argument, 25% by default will be reserved for the test subset. And I remember this approach right here is making use of this tool through scikit-learn, where the algorithm will randomly split the data to different variables. And we have a train, we have X train, X test, Y train, Y test. That means that this function is going to return 4 different things, and those things are going to be placed respectively into these variables. Now, what I want to put in first are the arrays that are going to be involved in my model. So that means I want to interact with the first one would be the feature. So I'm going to go ahead and call the feature, which is, I'm going to put double brackets here and put TV, and then put values. I'm just going to put that because I don't want any warning signs to happen when it comes down to running some of my models. Then I'm going to use the other array that is representative of my target, and that would be cells. So df.cells. If I want to use the test size, right, it's already by default in the backend set to 0.25. I can play around with it, and let's say that 50% of the data is going to go into the test subsets, and then the remaining one would go into the train. We are dealing with 200 observations, so we're dealing with 100 test, 100 train. Now, if you are following along and want to get the same results as me, then you would want to use a keyword argument called random state with the same value. So I'm going to put the value of 100. Now remember, train test split, it randomly chooses the data points to go into the respective sets, train or test. If you don't have this set, then you're going to have different values going into these variables, and then you might get different results. That's not to say that it's incorrect, which is not, but the whole purpose of random state is for you to be able to reproduce what I am doing here as well if you're following along. So I'm going to go ahead now and I'm going to make use of all of these here. I'm going to run it, and I didn't get a syntax error. I'm happy with that. And I'm going to look at the shape of one of the variables. So I'll look at this variable. Now there should have been some values that were unpacked from this function into the respective variables. I want to see how this looks, right? So here are the values that are for the train, right? Now, this value, this value, this value, all of these values represent TV expenditures, right? That are coming from the data frame. Now, if I use X test, right? So let me do a print here and a print here, but you know what? I want to do a len function on this just to kind of get the, just to get the counts. All right. To be clear, train count, and then test count. So that we have 100 for the train, 100 for the test, just looking at the train test for the X's, right? You can play around with the Y, it's going to be the same values, right? Now, once we have it split, right, and these were randomly split into the respective variables, I can now use, I can instantiate the model. So let me go ahead and instantiate a model. I'm going to call this reg, and I'm going to use the linear model. Let me just make sure I spell this correctly, and that's going to be based off what I have here. So, okay, linear regression is what I want to put in here. You can go ahead and do that. Here we are. So it's not linear model, it's linear regression, and then a set of parentheses here. This is how you instantiate the model, right? So this instantiates the model. And now that I've instantiated the model, I can now this variable I'm calling rig has these certain tools that this function is capable of handling. So I'm not going to refer to linear regression. I'm just going to refer to the variable. And if I want to use the fit, meaning I'm going to go ahead and now create the model using specific data. So I'm going to use the train data to create that model. You're always going to fit the model with the train, right? And that's what we have here. Oh, excuse me. And once that model is created using that data, I want to look at the score of that using the X-train data just to see how it did, right? Now, I'm gonna go ahead and run this. All right, let's see what it says. 2 positional arguments on the fits. Oops. All right. Yes, of course. I did a cut rather than a copy. So there we go. Run that. There we have our. This right here represents the R squared, right? So I can see right here. There we go. Now I want to say train. So that means what we did when we split it, we're creating this model using the train data and seeing how well it did. And it 0.82, 8.25, it's pretty strong in terms of how well this model is doing. So I'm happy with the strength of this model. We know that it's closer to 1, 0.82 is closer to 1, it's pretty strong. Now, what I'm going to do here is I'm going to use this model that I created, right? It's the model now is that rig variable. I'm going to call that rig variable in this cell, and I'm going to use a score method, but now I'm going to put in the test data, right? That means I'm feeding the model that I created initially, right, with the train, and I'm now feeding this model with unseen data. And we're going to look at its R squared for that, okay? So now I'm going to run that, and I get a 0.777, so on. So this is still even though the R squared is a little less than the R squared with the train, we do get a pretty strong R squared for the unseen data. It looks like this model that I created in saying that television expenditures will predict the target, which is unit sales, right? Pretty strong model. Let me go ahead and just create a label here. There we go. Okay. So it looks pretty good when I fed it with unseen data. Right now, this is an important part in machine learning where after you train it, you want to give it new data. what I did in the first demonstration is I used all the data, and that's it. I didn't have a train, I didn't have a test, and that could be problematic in terms of generalizability. generalizability. Now, I could use the attributes to get information related to the model. So I can get the y-intercept, I can get the coefficient, right? And these are attributes coming from the reg model that was created. So it looks like I'm good to go when it comes down to that. I can also do a prediction. So if I wanted to predict this, I can say reg.predict and then open up double brackets and put in a value 50 for like $50,000 television expenditure, run it, and this is what it predicted. Right now, although the values might not be too far from the earlier example I did where I ran all the data rather than have a train test split, that's by chance, but this would be the approach to take where you first train the model and then feed it new data. Right. Now we could visualize this model, and I can go ahead and demonstrate how this would look like. It'll be a little lengthy here, but I can go ahead and see how this would look like by creating a plot. And now this plot is going to contain the train, the X train values, right? So if I say X train dot values, then here say reg dot predicts, and I'm going to just put in the X train values inside, right? If I run it, let's see here, let's see values, let's see. Yes, I don't want to remove that. And I'm probably gonna have to remove this now too. All right, there we go. All right, so, and the reason why I'm removing the dot values is because they're already set in an array format. Now, and what I mean by that is if I do X train and take a look at it, it's already in an array format. It's not in a data frame. So I can go ahead and exclude that there. Now I'm going to make this red. And then I'll go ahead and layer this with another plot. And this is going to be it's going to be related to the X train again, but now it's not the model, it's the actual observed values. I write this here, and then this right there. Here are the observed values, okay? And I can take this a step further by placing the predicted values in this figure. So for example, if I say X test, and then I'll go ahead and put Y test, and I'm going to run that and see how that looks. Yeah, there we go, right? And it'd probably help to put some labels in here. So for example, if I create a label and say that this is the test data, and this would be the train data, right? Oops. Yeah, comma right there. And I'll probably need a legend since I'm including labels. And there we have it right there. I'll do a plt.show. So we can see the train set and the test set, and then my predicted model shown right here. I won't worry too much about putting, the title and the X and Y axis, but we know, all right, better yet, let me just go ahead and say X label so we won't get confused here, that this represents TV spending. And this represents, let's say, unit sales. All right, there we go. We have our prediction model line in red, and then we have the train and the test subsets shown in blue and orange respectively.